Let me open the software. Initially 2022-21 version is there, so that I want to open it. So whenever you will also open, just what I want to say, you can, wherever the software is installed, either you have installed in download folder or you have installed in C drive or D drive, anywhere, whatever the directory of your installation path, you can locate in that particular directory and click on Device Studio 2021 or 2022, whatever the version you have installed. Maybe 2021 will be there, B version. This is a version. In this particular folder you can locate yourself during the hands-on session. This session you just uh, keep it listen so that you will get to know about the things, and then go to the bin folder. In my C drive, Device Studio 2021B, and under that there is a bin folder is there. I will click on that Device Studio application file. It can be installed majorly on Windows applications. Okay, I click on skip login. So you also need to click on skip login. There is no need to provide the user ID and password. You can click on skip login. It will open your user interface. Now once it is done, then the new window will be open that will ask you to create the new project. So I click either you can create a new project from beginning. If you already working, let's suppose you already have the software, you are working previously, then existing project you can browse and you can resume your work. Okay, but since we are a beginner, we are working on first time, so I want to create a new project. Below one option is just to create a to open the existing projects. I want to create new from scratch. I click on open it, and now click on desktop. In the desktop one, you can define the name of your project. Let's suppose you want to define the name of the project. It's called hands-on or webinar or nanomaterial, whatever the name of you want to give. Nano as an example. This is name of my project. Nano HPF is a complete project file name, whole project name, not a material file. It is a project name. In that, all file input, output, and all those will be stored. And I maximize the screen. This is a one. This is a user interface that is called Device Studio. As in the presentation, I told you, Nanodcal is background calculation engine that will run in the background, that will calculate the property. But for the front end, you require the interface for modeling. In some tool, maybe this front end may not be there. Even maybe in quantum expression or in BASF or many maybe there. But front end is also important where you can concentrate on your physics. It can save a lot of your times. You can find it once you will explore it. This is main interface. I want to give you the idea about this interface. That all toolbars are there. Okay, this is your help option where you can create your new project, you can import your projects, you can import your material online. These options are there. Okay. This is all option: edit, view, build. Builder is there. Build is called builder, which will build your structures. Whatever kind of structure you want to build, that will be built with the help of this build options. So builder and simulator, you can see builder and simulator. The main, this is the visualizing thing you are seeing here. This is called Device Studio, and simulator is called Nanodcal. It is integrated with the Device Studio. It is not a separate two different tool. It is integrated tool. So Device Studio and Nanodcal both are integrated. We have other options also. If you want to go for only visualizer, only device, only simulation part, that can also be provided as a options. So whatever the goal you want to get, either you are a very expert in writing the code or scripting, then calculation engine Nanodecal alone can also be provided with the application file. But if you want to get some sophisticated interface, then this Device Studio can also be make a bundle for you. Both options are there as per the user's demands. Now you can see this area is showing the project Nano. It is this area is basically the byte area we will call as a input file and output file. Input file, output file will be explored in this project window in the left side project nano input file, output file. Bottom of that there is a property bar where it will display the property of your crystal, molecule, material, device. The property will be displayed in this second bar. How many atoms are there, or how many that lattice point, coordinate points, and their vector coordinate points. Property of crystal, whatever your material is there, that material property, crystal information or device information will be displayed in this property bar. This is input file, output file. This is property bar. Bottom one is called job manager. Job manager in the sense your calculation task manager. Your script input file, whenever it is running the program, then it will be managed in your job calculation log file on the bottom of the page. Top toolbar will be there. I will also explore you one by one. And model in the middle area, this will be called as a builder area, or we can call whatever the main visualization area will be there. Let me take one material as an example, then we will explore the more things. I click on the file option, then click on the import options. Once you will open your tool in the second session, you will also find these options, whatever I am seeing here. In the file import option, click on import local and import online. Import local in the sense the software where it is installed in your computer. In that particular location, there are some materials are present. There are materials some presents, some molecules are present, some insulator, conductor, semiconductors. All these materials are stored in your local computer. And second option is also there where you can also import the material from open source library. Initially, we will go for the import local where my material are there in my C drive because the software is installed in my C drive device studio. So I will locate that particular folder in my C drive, this device studio 2021 and device studio. Here you can see the material file, pseudo potential library, software examples, these are there. Initially, I want to upload the material from my own database in the software. Once I will go to this material folder, there will be a lot of materials are present. Some molecule that is called zero dimensional material, one dimensional material. This is molecular library where polystyrene, polyethylene, crystalline type of molecules are there. This is molecule library. Even you can see the software can also upload the HZW, XYZ, CIF, XSD, postcard, SC input, relax.json. These are the file extension, other file format. Suppose you are working on Gaussian or any other tool, you can also upload the crystallographic information file. CIF file can also be get it uploaded directly. One dimensional material file that is called nanotube, different chiral vector. This is different nanotube material are there. Similarly, the two dimensional material, some nobility material, black phosphorus, bismuth, arsenide, hexagonal boron nitride, and some axene, graphene materials are there. Apart from that, 3D material, conductor, insulator, layer material, magnetic material, oxide material, nobility material, semiconducting material. These are all folder. Each folder contains the material. You can see here whatever the material you want to do the search, that material you can predict from our existing library. If any material is not present, as an example I am telling you, then you can also upload your own material where simply XYZ format or CIF format you can upload it. Even if you don't want to upload, you can also have the option to create your material. So there are four ways are there. By that way, basically you can work on that particular material. One thing is that from our library. Second option is called you can upload your existing material file, XYZ or CIF. And third option is called you can create your own material in the tool, in the user interface, where you can define your lattice parameter, their coordinate points, cell length, and all the things. You can also create your own material in our interface. And fourth one is also there, where third party open source database you can directly search and import. So this is just one story of adding the material in our interface. So let me take as an example. Either you want to working on semiconductor or any other material. As an example, we can take MOS2. As an example, you can take any one. I want to click on select on that and click on open. Once I selected it, then I maximize this screen. It is now loaded. Now once it is loaded, then you can see I have taken the MOS2 material, but there are some unwanted atoms are there. You can see this is not a single MOS2. This is one sulfur atom, yellow color. There is one another sulfur atom. This is molybdenum. But if you want to simulate only single MOS2, then you can simply draw the rectangle, just hold the right button and draw the rectangle. It will get it select. Hold the left button and draw the rectangle. Hold left mouse and draw the rectangle. It will get it select. Then you can see here top toolbar option is there. This will help you a lot. This will help you a lot for creating any complex or manipulation in your atomic part, or measuring the distance, converting your material into the device or molecule. This top toolbar will be helpful. Let's suppose I have selected these two atoms. I want to delete it. I simply click on delete atom button. This will delete the particular atom. That selected atom is deleted. Similarly, if I want to click on particular single atom and click on delete button, it will get delete. So undesired atom we can delete, and that required atom we can keep it up, and then we will get it simulate that particular material. Now you can see there are two MOS2 crystals are there. You can also rotate it. If you want to rotate, you can see rotations. You can simply hold the right button and rotate the mouse. So this is a unit cell of the crystal. Complex atoms can also be built by yourself, and then you will see the things. If you want to see on different view, X by view, by Z view, XZ view, by X view, any view, whatever the view you want to see, you can see it. Now I want to select the atom, and then I want to delete this atoms also. This is atom selected. I can press the delete button. Now there is only single MOS2 is remaining. This is a zoom button where you can, once you press it, then you can zoom your particular atom. Once you will have a complex structure, you want to zoom particular atom, then it can also be get it zoom. If you want to measure the distance between the atoms from one bond to another bond, you can see here, you can simply select the atom and click on this Z matrix, where the bond length you can see it in between two atoms, how much bond length is there. So this atom and this atom, molybdenum and sulfur, one molybdenum, one sulfur atom, the distance is this 2.42509 angstrom. It is a bond length distance. This bond length from one center to center is distance can be measured. Now if you want to measure the distance, this is a distance measurement tool. You can press on one atom and you can see here, this is distance is measured. This is distance measurement tool. Similarly, for any atom, procedure is same. from one center atom to another center atom, you want to check the length of your seat or whatever, the measure can be distance. So distance can be measured. You can see here the multiple options are there. Not only a distance measurement tool, it can measure the angle also. It can measure, that can also be measured. And this is like a vector can be measured, or linker bond can also be measured. This is a measurement of different atomic positions. Now let it simulate this simple MOS2 crystal, then we will go for other options as well. For simulating the single crystal, we have to go to the simulator. You can see here simulator, and then since this session is for Nanodcal hands-on training session, so we will explore more about Nanodcal. I click on this Nanodcal SCF calculations. Once I click on SCF calculation, self-consistent field, SCF stands for self-consistent field for the crystal, where electron temperature are there. You can also change the electron temperature, whatever your electron temperature, you can manually edit the value as per your need, you can define it. Energy cutoff, exchange correlation functions, LDA, GGA with PBE functionals are mentioned. For hybrid function, we have a different tool. This is for simple LDA and GGA functionals. And K point samplings are there. You can define the number of sampling point in A, B, C directions. Number of sampling points. This is iteration control. You can define the density matrix, Hamiltonian matrix, maximum steps, mix methods, mix rate, mixing variables, starting points. This is iteration control parameters and basis sets. This is density functional theory parameter, where all basic settings, iteration control parameter, where it will solve the Hamiltonian equations first, and then density matrix, and basis sets are there with the different basis sets, whatever you want to use the molybdenum, you want to use a PBE functionals or any other basis sets. So go to the user defined. If user defined basis sets you want to upload, you can see here the neutral atomic database basis sets, particular material specific basis sets, either LDA, GGA, or double zeta polarized, single zeta polarized, double zeta double polarized, single zeta double polarized. Different kind of basis sets are there. That basis sets you can pick up from this library. By default, it will take as per the crystal selected. But if you want to change it, then not only LD, GGA you can take, double zeta polarized, single zeta polarized, double zeta double polarized. User defined it is possible. Then next goes to the spin type. Either it is a collinear type spin, without spin, general spin, spin polarization. So select the polarization spin. You can select this general spin type, spin polarization. Without spin, you can select it. Collinear spin, you can select it. And general spin. The type of spin and their spin orbit interaction. Rho, theta, phi, as per the need, you can select it. Initially, let it simulate without spin. But if you want to see the spin up band gap, spin down band gap, that in that case only this spin type need to be selected. Now I will click on this generate file. Once I will click on it, it will generate this crystal scf.input file. You can see here crystal scf.input file has generated. mos2.hzw is the material file. The material file that I have uploaded from my library. So HZW is the proprietary format of this company, and this MOS2 is the folder which is created automatically once I generate this scf.input file. If you want to check the script, if you want to check the code, then right click and click on open with. Once you click on open with, the auto generated script, auto generated code you can visualize. Since this is single crystal, there is one molybdenum and two sulfur atoms are there. So whatever their points, coordinate points of the atom that you can see in the script, whatever the electron temperature, whatever the energy cutoff, whatever the type of functionals, k-point sampling, cell vectors, spin type included or not included, iteration control parameter, Hamiltonian mix rate, maximum step, starting points, and their output calculation file. This is auto-generated script. You have no need to write the script if you are using the device studio. Once you have a complex structure, then the script will be automatically increases and it will generate automatically. This is just for your information that I wanted to show you. Whenever you want to check the script, then it is also get it possible. Now let me try to run the calculations. So I will right click and click on run button. Once I click on right click and click on run to run the program, so what I need to do, I will right click and click on run program. How software is easy to run the simulation that I wanted to explore you. Now I want to run the system, run the calculation in my laptop only, not on different computer. If you have a workstation, then you have a 16 core, then you will see a 16 core. For parallel calculation, it will reduce the simulation time. So let's suppose I want to run the job on 4 core, then I parallelly it will run the calculation on 4 core multi-coring and click on run the program. This is run program button. Click on run button. Now you can see here the calculation is running. Status, you can see the calculation is running. If you want to run the job on server, on different server, not on your particular computer, then it will also be possible where remotely or by connecting the server with your personal laptop, it will also be possible to run the job. Now calculation is running, as you can see the status. That's why this bottom side is called the job manager, which will show the script scf input file and their status, either it is running or not. Simulator and Nanodcal. Relaxation is also possible. If you want to relax your structure, optimize your structure, then optimization, relaxation is also possible. Initially, since I am going to explore the feature of the tool, then later on you can also optimize it. Okay. Now I want to go to the analysis part. What kind of property you can calculate? You can see here the material specific property. We will go to the device level later on. First of all, the journey will start from the material. So you can see here density of state, you can predict effective potential, total energy, band structures, charge, Hessian, phonon, electron density, potential, eigenstates, whole band structure, complex band structure, jet phonon, you can see here. These are the property that you can calculate. These are all material crystal related property. And out of all these analysis, you can select what property actually from out of these all you want to calculate. So those property you want to calculate, that you can select it. Rest of them there is no need to select. Only the desired output you can select as per the need. Once the desired output is select, you can see this effective potential and transmission channels. These all analysis are there. You can click on generate file. Once you click on generate file, as from the beginning I told you, this is my input file and output file. So all input file is generated. We have not run the simulation of our analysis, only input file calculation we have run it. That's why you can see the log.txt file. You can also open this file and see the calculation log file. This is calculation that is run. And how much time it took to finish the calculation, around 23 seconds something. all calculations were finished in 28 seconds. But dependent on the number of atoms, once the number of atoms will be increases, once the iteration control parameter will be increases, k point sampling and more complexity in your structure will be increases, then simulation time will be also increases. It may be 1 hour, it may be 1 day, it may be 2 day, it may be 5 hours, depending on the input parameter as well as your system configurations. Either you are using a workstation, you are using a good high-end cluster, supercomputer, normal laptop, whatever the processor, RAMs, speed, dependent on that the calculation time will be differ and type of licenses. So this is all about that text file. Now these are my analysis file that I want to get it simulate. So I will run my all input, right click and click on run button and click on run. The next total energy, I will right click, click on run button and then click on run. Our tomorrow session will be on advanced levels. Okay. Where other speaker will be there that will also explore you about these tools. And now I'm putting all my input file to run the code. I'm writing clicking and you can see here all calculation is running. Some of them who has not completed, they are in the queue. And one by one automatically it is getting finished the calculation. It is running the program and getting finished. And once it is finishing, the output file in XML or DSF format it is generating. Now if you want to see the output, you can click on band structure and click on show view. It will show your output of your material. This is a band structure plot. Simply as you have got to know what are the simple things that I have presented. We can also change the Brilliant zones root points as per the needs. Now this is a balance band and this is a conduction band on top. Bottom zero level that is called green Fermi levels. If you want to change the minimum and maximum position of X, you can also see it or even in the by positions. If you want to explore your data, you can see here export option. You can export your data in form of PNG file, JPG file, PDF file, TIFF file or text file. Whatever the format you want to export it, you can export your data. Image format, you can also get it image. Even if you want to export in the form of text, you can also export. Let's example, I want to export on desktop text and click on save and export. Similarly, other output is also there. If you want to see the total electron density, right click and click on show view. This is total electron density for 2 atoms, 3 atoms, MOH2 single crystal. The vacuum in this unit cell we can also reduce. I will explore you how. This is 3D model. Similarly, if you want to see the 2D model electron density analysis, this is two-dimensional electron density plot. This is one-dimensional plots. One-dimensional, two-dimensional plates are there along x-axis, along y-axis, along every z directions. So whatever stereoscopic display, planar display, you can see the output in that particular format. So 2D plane, 3D plane, 1D plane, these are different output in that particular direction, x direction, y direction, or z directions. And similarly, if you want to export this image, you can see these are different 3D viewer are also there. You can view your structure in x by z or zx. Different visualization will be there for you. If you want to export it, just a minute. If you want to export, you can see here export image, and image you can export it for this total electron density and click on save button. Now I want to show you the desktop where the data is exported. Just you can see here this is exported output in image in the form of data, raw data. This is raw data of band structure that I have exported. Now similarly eigenstate, if you want to see for this simple two atom structure, complex structure we will also create and explore. And this is a 2D model for eigenstates and Bundy model. Okay. For one dimensional, two dimensional, and three dimensional, as per the desired goal, whatever the goal of your output characteristics, you have to select that and then you can plot it. And transmission channel output you can see here. This is transmission channel, number of transmission channel, average over transverse key space. From minus whatever the range you want to see here, and you can apply. So that particular range you can visualize your characteristics. This is simple that I have taken. Now you can see here this property bar, which is displaying the vector coordinate point of A, B, C, X, Y, Z, and total number of atom and total area of this unit cell. Whenever the number of atom will be deleted, this number of atom will be reduced in this particular atom. If you want to reduce the vacuum, then what you have to do? You can simply reach to this convert to crystal, where you can reduce the vacuum in your unit cell. In Z direction you can see there is 18.41 angstrom, but in A direction you can see there is a 3.16, B direction 2.74, and C direction 18 point something. But if you want to make it, let's suppose 2.5, 2.6 or something, you can see here this atom has been removed from the lattice. But if you want to make it, let's suppose 4.5 in the Z, then still it is nearby. But if you want to make it 6, then still it is under near to that. If you want to make it 8, then it is still near to that. But let me see how it can be done. Click on build. Then you can see here the vacuum has been reduced, but the position of this atom is not properly aligned. What you can do, you can draw the rectangle by left, hold the left button and press the center. All atom has selected. I can click on center. It will move the position to center. Now vacuum has been reduced. Even more vacuum as per our need, we can reduce the vacuum. There is no issue at all with this. This is simple structure that I have taken it and wanted to explore. Now I would like to explore, take some more element, more atom that I will keep you explain. Let's suppose I want to take one graphene. Let's suppose I want to take this graphene, two atoms. There are two atoms are there only in this graphene layer. Okay. These are two atoms. But you want to make it complete sheets. Okay. So what you can do here, you can also go to this build options. This build option will help you to create the desired shape of your structures. There is redefine this crystal. Single crystal is there, but you can click on this redefine and define this crystal in B directions. Let's suppose you want to repeat in B direction 10 times. So you can see here B is called top direction. 10 times it is repeated in B. You can also rotate and you see here this is B, 10 times it is repeated. And if you want to repeat 2 times or even 4 times in A direction, then click on preview. Now 4 times in A direction and 10 times in B direction. I have repeated simply the single crystal. You can see this is single crystal, but what I did 4 times I have repeated in A and 10 times I have repeated in B. So redefine the crystal by expressing the new cell vector U, V and W as a linear combination of current cell vectors. And then see the preview before build the structure. You can also make it body centered. You can make it face centered or body centered as per the needs. You can create it. Okay. So it is not properly aligned for body center. You can make it 10, 0, 0, and here you can make it 0. Sorry, 4 times. That's okay. And then click on preview. And then you can click on build button. This is now built. You can see your seat is there. Similar to that. From single crystal, I have repeated it. This was single crystal, single graphene. Now second input file, graphene underscore redefined dot hzw. That is called defining the crystal, defining that material again. That's why you can see this screen. So first was MOS2 material, graphene and graphene redefined. Now you can see in the property bar, it is displaying the property. Vector coordinate point, total number of atoms, and total area of this lattice. Total area of this lattice, vector coordinate, and total number of atoms. Okay. Now if you want to add some doping or you want to create the defect, so you can select the particular atom. Now you can see I click on this atom. You can also zoom for the time being. I just zoom it. This is your seeds. I deselect it. If you want to select again, click on any atom like that. If you want to delete it, you can simply press the delete button. If you want to replace the atom, you can simply click on replace atom. And once you will replace it, whatever type of doping from the periodic table. This is periodic table. How this periodic table come? I just select the atom that I want to replace, whatever atom, and click on this option, replace atom. And here you can see the type of dopant is there. From the periodic table, you can select the N type, P type, or in particular material you can dope. Let's suppose as a magnesium or whatever you want to dope, select it and click on OK. Now you can see the color has got changed. This is green color that is replaced this magnesium with the carbon. You can see I click on it. Now you can see this magnesium atom XYZ coordinate point. If I click on this particular atom, this is XYZ element coordinate points. Similarly, not only single crystal, if you want to do particular lattice, like let's suppose this hexagonal sheet you want to do, I draw the rectangle and select it. It is got selected. I have a multiple options. I can rotate, I can delete, I can create mirror, I can move the atoms. So these are multiple options. Either you want to delete, you want to replace, you want to move the atom. So this is movement in X direction, Y direction, Z direction, particular distance you can move, particular vector, particular screening view. If you want to rotate, this is rotation clockwise, anti-clockwise, 30-degree angle, 40-degree angle. You can define manually the angle, at what angle you want to rotate it. But let's suppose you want to dope it. So I will click on this replace doping and select the type of dopants. But let's suppose boron I have taken it. It's now replace. These are different color atom that you can see. Now it is a one single layer which is doped with the magnesium and boron. Okay. Even you can also delete, rotate, defect, whatever kind of defect you want to create, it is getting created. Now either you can simulate the single layer or you can also make it bi-layer. Similar kind of layer. You can create the mirror, one layer on the top or one layer on the bottom, or you can rotate whatever, it can be done. If you want to simulate, simply go to the simulator. Since the number of atoms are 80, which may take some time, so if you want, I want to delete some of the atom from out of them. Let's suppose as an example, you want to delete some atoms. You can select that particular atom and press the delete button. It is now deleted. Select it and press the center button. It is in center. Now atom has been reduced to 54. Earlier it was 80, it is reduced to 54. So similarly, you can create that kind of desired shape. Either you want to make a Z shape or C shape or any shape can be created by selecting the particular atom. Let's suppose you want to delete this shape, T shape, Z shape, A shape, any alphabetical shape you can also create it. This is like I have deleted some more unwanted atom. So it is like simple way that can be created. Now I want to go to the simulator and go to the analysis Nanodecal part. As I told you, Nanodecal is background calculation engine. I click on SCF calculations. Now here this is basic settings, the number of temperature range, similarly previously whatever we have done. Energy cutoff, exchange correlation functions, LDA, GGA, number of sampling points, density matrix, Hamiltonian, basis sets. Now you can see here the basis sets has been changed. Earlier for MOH2, molybdenum and sulfur basis sets were there. But since this is a boron, carbon and magnesium, so 3 atom basis sets automatically default selected. You can also change it if you want. Click on generate file. Now this crystal SCF input file has generated. I can right click and click on run program. Now program will run in the back job manager task. You can see here the last one SCF input for this graphene nano driven redefined crystal input file is running. And parallelly, if you want to select the analysis file, you can also go to the simulator and go to the analysis part. From there, same need to be followed. You whatever the plot you want to calculate, you have to select it. These all analysis are possible. Okay. And click on generate file. I will right click and click on run program so that automatically once the main input file finish the calculation, then automatically it will execute the next input file. These are all our input file. So one by one I am putting all in queue. it is running. In the meantime, it may take some time because it is live simulation. So live simulation, definitely it takes some time in the calculation. Then there are around 48 atoms are there. Okay, now in the meantime I want to explore you some more things. You can see here this builder is there, where device you can convert your material into the device. You can make the interface builder, surface clip, molecule, graphene nanoribbon, graphene nanotube. Grain boundary will also be possible once you created the surface plane. Nanotube, nanowire, disordered graphene, zinc blend, icosahektone, cubohectone. These are different types. If you want to directly create a graphene nanoribbon, you can simply go to the graphene nanoribbon. Now this window has opened. Define the unit cell. Calculation is running for previous input file. But in the meantime, I want to explore you more capability of the interface tool. This is new. Define the unit cell of nanoribbon with the Kral vector. That is called N and M. You have to define the site A and site B. Okay. If you want to take it carbon, then you can take it carbon. If you want to take it any other atom, then you can also take it any other atom. Simply click on that, you can take that particular atom. So that carbon atom, you can take it. Or but if you want to take boron based, you can select the boron. Periodic table is already there. It is up to you what kind of nanoribbon you want to build. If you want to define the bond lengths, different bond length, default 1.42 angstrom bond length is there, and any other thing as per the needs you can select. Passivate dangling bond with the hydrogen atoms. It means if you want to protect your seed with the hydrogen atoms, then you can activate this checkbox to passivate your atom or seed with a dangling bond hydrogen atom. This is number of structure n times n and m value, that is Kral vector. You can see and click on preview. Now armchair, zigzag, armchair, what kind of nanoribbon you want to create depending on the n or m value. So if it is different, you can also create the armchair type as well, or zigzag type as well. You can top and bottom side you can find there. This is called yellow color atom is called the dangling point hydrogen atoms. So you have to change as per your needs and click on build button, and you can also rotate, and as per the needs you can create it. The vacuum in the unit cell can be reduced also as per your needs. You can adjust it. Now from there, if you want to change anything, it can also be get it changed. So whatever shape you want to create, it's up to you. That any kind of structures can be created for you, and then you can dope and whatever defect can be created. It's up to the user. Now these are some other options are there. If you want to simulate similarly the graphene nanotube, this is for nanotube builder. Either single balled, multi-balled nanotube can be created. Carbon based, boron based. Simple option is also there. The type of atom you want to create on different sites. You can see it is created like that. Okay, and you can also dope in this particular nanotube as well. Simulation is running for that input file. You can see still the input file is running the calculation, but in the meantime you can see here these are some more functions are there. If you want to create the interface or you want to cleave the surface, you can see 1 minute. You can also click on surface plane. This is surface slab. You can define the Miller indices 100, 110, or 111. The plane, whatever the plane you want to cleave it, you want to define the slab thickness or vacuum, you can sleeve it.
Hello, hello, hello.
Yes, yes, please, ma'am.
Sir, whatever you are doing, no, sir, you have taken once whatever it is existing, right?
Mm-hmm.
Whatever, suppose in your already it is there, right? Locally it is available. That graphene, whatever single structure, then you have done the multiple times. Now, suppose if I want to design my own structure, the how
Mm-hmm.
do we do that one? This kind of symbol and all from where we'll get it, sir?
Now you can see in the screen there is a. I went to the file option,
Huh.
and
File.
then new option is there. From the
Yes.
beginning, you want to
Yeah.
create something.
Okay.
So device you can create from the beginning instead
Okay.
of taking from the default
Wow.
plugin type of
Huh.
things.
Okay.
This is a crystal. You can let it select it.
Okay.
In this crystal, you can see there is a space group. Whatever 1p1, 2p1, 3p2, 4p1 type of space group you can select. Multiple options are there.
Okay.
It is like for BCC, FCC, rhombohedral, tetragonal, triclinic, depending on
Mm-hmm.
that particular space group.
Okay. Okay.
And ABC value is there since it is hexagonal, so A and B is enabled. But if you will select any other, then that particular type of this lattice will be enabled. See, like simple, tetragonal simple. If you want to change the cell length, A and B equal to cell length, you want to define your own value, it will take it. Select the fractional coordinate points. Fractional coordinate point and select the primitive or conventional cell. From here, basically the new crystal can be created. Once you will define the ABC parameter and fractional coordinate points, multiple fractional coordinate points like that, then you will be able to create your desired shape from the beginning. You can see here, this is a default carbon, but if you want to take boron, you can change it to boron. If you want to take any other, you can take particular that atom and see the preview. So crystal structures, either it is a primitive cell or it is a conventional cell that can be created by this new crystal structure builder. And then click on build, it will get it built. As an example, it is like that, can be created from the beginning. Other option is also there. Similarly, if you want to build the molecule, this is molecule of builder is there. Even more advanced molecular builder has released in 2022 version. Let's suppose you want to create a H2O. This is simple molecular builder, but we have a advanced version of molecule is also there, where trivalent or different symmetrical or asymmetric type of nano builder can that the molecular builder can be built. As an example, let's say you can see here molecule you want to build, or even this earlier atom. Let's suppose this is one crystal. That existing crystal can also convert into the molecule. This is MOH2. You want to remove the lattice. Totally the lattice you want to remove it. Click on this convert to molecule. Your lattice will be removed. Similarly, for any structure, if you want to remove your lattice, simply click on this, remove it. It will remove it, that particular. Okay. Now, Device part we will cover tomorrow mostly. This is just for material session today. Now if you want to create a retro structures, let's suppose you want to make an interface. I want to take two material. Let's suppose I can take one silver atom, and next atom I can take as a gold. So these two atoms I have taken, silver and gold. Okay. If you want to create a retro structures or even this other options is also there. You can click on the interface builder. This is interface builder. In the interface builder, you can select that particular material. Like I want to make it silver that I have already imported in our projects, and I can take another material gold that I have imported, and then click on match and see the preview. You can see here the interface in between gold and silver, and see the lattice matching number of atoms. Strain on first surface, strain on second surface, or both the surface. You can see it. This is total number of atom on this particular points, number of atoms on this particular atoms, and atoms number, angle, rotation, mismatching, area, strain B, strain theta, that is generated. If you want to make more constant grid size, let's suppose 10 by 10 or 10 by 8, you can click on match and see the preview. This will get it increased, and click on build and see the interface structures in between the gold and silver. Similarly, any other material, as an example I took the gold and silver, but let's suppose you want to take something else. It depends to the users. And then we can simulate such kind of structures as well in this tool. How it will not take much time to create it. If you want to measure the distance, let's suppose you want to measure the distance, what you can do, you can see here from which point to which point you want to measure. So this is like distance. Let's suppose as example this atom to this atom, and this lines, red lines has been drawn. I can maximize. You can see here 27.535 distance is there from one atom to another atom. Similarly, you can also measure the angle. This is angle measurement. So angle, you can see here 33.04 degree angle in between this one. This one is red line, dotted line, and this is second red dotted line. And how much is the angle from this? It is showing 33. So angle measurement, dihedral measurement, plane measurement, vector measurements, these all things can be done.
Hello, sir.